Hello, my name is Dr. Deanna Soper, and I'm coming to you from the University of Dallas. I'm here today to present to you a project called FathomNet Education Experience, designing and implementing an integrative remote experiential learning curricula to better understand marine biodiversity. This project was completed in collaboration with a number of different partners: Kakani from Mbari, Larissa from Bates, Leila from UCSC, Ben from C Vision AI, and a number of different students that I will acknowledge at the end of the presentation. The ocean is deep and vast, and there is a lot to discover in this habitat. And one of the biggest questions that I have is, what is down in the benthic deep ocean? I love to connect my students with this particular habitat because I think there's a lot of people that don't understand the level of biodiversity that we actually see there. Many people envision the deep ocean as being some barren place, when in fact, there's a whole host of different organisms that seem almost alien down there. So it is one of those things that I love to connect my students with in this habitat. In order to do so, we do collect a number of different videos, hundreds or even thousands of hours of video, by using what's called an ROV, or a remotely operated vehicle. These vehicles have complex computer systems as well as even arms that can collect samples. But when they are in the deep ocean, they are video recording from at least one, if not multiple cameras. And we can collect all of this video data. But one issue with that video data is that it is not immediately quantitative. And as a scientist, we want to quantitate exactly what is out there in the deep ocean. The other problem, besides quantification of the video data, is that there is a problem of data accessibility. Many times, the footage is not easily searchable or quantifiable in its immediate format. And so we need to try to make that the videos more accessible for both researchers and educators. It does require manual annotation of footage right now, which means that you have to have experts that go through the footage and attempt to ID everything that was seen on the video and take note of where those organisms were observed within the video. This requires a significant amount of time, training, and expertise. Footage is also frequently stored in non-streamable formats, including on hard drives that is inaccessible to anybody unless you're in possession of those hard drives. So there's a number of different things that we can do to make the data more accessible, including the development of streamable formats for these videos. There's a number of organizations that have attempted to start to address these issues, one being Mbari. They have developed the Video Annotation and Reference System, or VARS, which includes a query tool that students and or researchers can utilize in order to access data and analyze it. That is a comprehensive database that contributes to things like the Deep Sea Guide that you can utilize in order to search expertly annotated or expertly identified organisms, as well as FathomNet. FathomNet just came online last fall and is utilizable by anybody who has an internet connection. And there are many different databases that are tools that actually are contributing to FathomNet, including Tater. So that brings me to the right side of the slide. NOAA is another partner, deep sea partner, that helps to collect this sort of data. And the NOAA has data archives that store all of this information. And that information, the video data, can be uploaded to a brand new tool that's under development by C Vision AI called Tater. Tater is a software that is being attempted to be developed in order to analyze this video and undergo automatic feature detection. And so we aren't at the point where the software has the ability to do that yet, but we are in the process of trying to get the software to be good at feature detection, object detection. My work here at the University of Dallas has highly contributed to this project, and it is a project that is ongoing. One problem, though, is that more hands on deck are needed because this process that I've just described to you is fairly labor intensive. And as a result, we need to make thousands of different annotations or localizations of the data in order to teach the computer what looks like what. And so as a result, one solution to that problem is both research students as well as education. So this project started in the summer of 2020 when COVID hit. I needed to take my research program and make it more virtual. So the project Minuet, which I'll tell you why and how that's named that way in just a minute, was started in the summer of 2020 with these research students. Versana, Maria, and Carol Ann were fundamental in getting this project off the ground and developing protocols that we ultimately used and took into the classroom to teach a wider body of students. Minuet stands for Machine Intelligence, NOAA's Underwater Exploration with TATR. And the reason why we wanted to make the acronym Minuet is because we did utilize video footage for this project initially from the musician seamounts, which are seamounts just north of Hawaii. The video was collected as part of the Capstone project, which was a much larger project, which included a series of expeditions that attempted to better understand the biodiversity, abundance, and distribution of living organisms in the Pacific Ocean. So Expedition 1708, or the musician seamounts, is what we focused on. There were 22 dives on 17 seamounts across this range just north of Hawaii. The different areas were broken up into different geologic and geographic areas, one being the northern group. There were two that were in intermediate latitude, and then there was a host of dives that were completed in the southern latitudes. We also collected data off of 4 different seamounts. There were 3 ridges, 1 bank, 5 Goyat seamounts, and 8 conical seamounts. So due to the diversity of the latitude and the locations, as well as the different types of geologic formations, it allowed us to be able to actually analyze the data and biodiversity of living organisms there. So in order to begin this is what the TATR interface looks like. It is NOAA uploaded the video data into the platform, and there is media streaming. So if you have an internet connection, you have the ability to actually log into TATR and get to your video data. The second thing that we do is we accumulated the expert IDs from people at the University of Hawaii. And so they completed annotations and that they were able to say, hey, in this location or around this area, there was a Chrysogorgia, but the computer at that point didn't know what that looked like. And so that's where my students come into play. They took these annotations and they draw boxes around these organisms to teach the computer what these different organisms look like. In that way, we're creating training data sets for the computer to begin to learn what these different organisms actually look like. But we wanted to expand on this research project and take it into the classroom because we wanted to engage more students and connect them to the deep sea habitat. So Bates College Larissa taught a class at Bates College called STEM Scholars in the winter of 2021. There were 18 students and there was a host of different majors, all sophomores, and some level of racial diversity. The University of Dallas also I developed a course called Underwater Exploration. It was a little bit different in format in that course spanned the entire semester, whereas STEM Scholars was a smaller part of the semester. I developed a lab manual that assisted students in walking them through the process of learning how to identify organisms, classify them, and then identify them on TATR. This was taught in spring of 2021, and I had 11 students, mostly biology majors and mostly seniors. 1 African American, and 1 Latinx. This is the front face of the lab manual that I developed. And the funding for this curricular development was provided by the National Marine Sanctuary Foundation. We implemented this as a trial run in spring of 2021. I do plan on rerunning this course again in spring of 2023. This lab manual was authored by myself and my student, Carol Ann Stone. The course was taught primarily by myself and Carol Ann, but Kakani, Ben, and Megan all helped me in that they actually zoomed into the classroom. You can see them there. This is a picture taken from my classroom. My students are at the computers, and they were zooming in to tell them about this broader project of video data analysis, accumulation, and analysis. So the course structure is, the first thing the students had to do was they had to learn about biological taxonomic information. They had to familiarize themselves with all the major animal phyla and be able to actually identify them on the screen. Students had to then also learn to use the TATR tool, and they had to learn those research protocols that were utilized and developed by my students the previous summer. The students then localized a dive from a completely different expedition. So we trained them on the data that we were working with the previous summer, but then we actually threw a new dive at them that had not been previously touched, and that resulted in 2,258 localizations across my students throughout the semester. Students were given the option of, after we learned how to do TATR and all of that, they were given the option of either doing a scuba certification at the end of the course or doing an independent project. 6 of those 11 students chose to do an independent research project and utilize data collected both from TATR as well as the VARS query data system in order to answer a question that they had developed on their own. I wanted to show you some data both from research projects as well as from the class that I taught. So these are 2 different projects that we have in my research lab. One student is interested in understanding biodiversity, abundance, and distribution across the different dives, as well as she has grouped them into the different geologic and latitudinal diversity within those series of dives. And another student was very interested in the association of Urelidae sea stars and their coral hosts. So she is looking at the abundance of the different coral hosts and was examining the association of the Urelidae sea stars with their coral hosts. Here she's actually found a strong positive correlation between the different coral taxa that they exist on and the abundance of those coral within the ecosystem. These are 2 examples of figures collected from my students in the course. And the left one is examining the depth distribution of Coryphaenoides. And the right is examining oxygen levels with the presence of the Humboldt squid. The curriculum is accessible here on my website. I do have a course website, so you are more than welcome to access the material. It's freely available online. And if you have any questions about it, please do let me know. We do want to take this research in a future direction, and that is we want to actually develop a better website for wider distribution of these materials. And we really want to focus on engaging minority-serving institutions. We want to continue developing TATR and push boundaries for automatic feature detection, as well as make video and data more accessible for researchers and educators online. I want to invite you to participate in the FathomNet workshop, which is going to be held virtually on March 31st and April 1st. You can register for that at tinyurl.com/FathomNet. I'd like to acknowledge my students and funding from the University of Dallas Marcus Fund, the National Marine Sanctuary Foundation, and NOAA's Office of Ocean Exploration and Research. If you have any questions, please do let me know. Thank you for listening.